Hi. This FYP is for quantitative analysis of smart contracts for vulnerabilities in Ethereum. Firstly, a brief background of this topic is given, the problem is then discussed, followed by the solution and lastly, the evaluation of the results. Ethereum is a global platform that is based on the blockchain technology. Blockchain is a time-stamped series of immutable records of data that is managed by a cluster of computers not owned by any single entity. Using Ethereum, you can write code, or smart contracts which can facilitate the exchange of money. As long as certain conditions are met, these smart contracts will execute by themselves. This is especially useful as we can save costs on intermediaries. The problem is that poorly written smart contracts in the Ethereum platform are susceptible to hacks. One notorious example is the DAO attack, which results in more than $45 million USD stolen. A single Google search will yield more articles of how Ethereum is exploited by malicious hackers to steal money. In this project, we will look more in depth in ERC-20 smart contracts. They are of interest because there are more than 180K compatible tokens that exist on the network. We will look at two ERC-20 contracts in particular. This is Beauty Chain Token. Currently, it is valued at $123 million and still trading strong. The other is Useless Ethereum Token. Currently, it has already been compromised, but the implementation is of interest to us. For the solution, we investigate the use of Solidity Instrumentation Framework (SIF) to check and prevent vulnerabilities. This means we are adding in code which are useful into the smart contracts. This constraint we are adding ensures that the total amount of tokens is conserved whenever a transfer is made. Subsequently, we will test contracts in the market using some tools. One of the tool is Truffle Suite. Truffle is a development environment, testing framework and asset pipeline for Ethereum. The other is the Modified Solidity Compiler and Ethereum Virtual Machine. Now for the results. This is BEC token. In this batch transfer function, there is an integer overflow which can occur at the line as shown. This can result in tokens transferred even when the sender has insufficient tokens. By inserting the constraint shown before, we can see that the attack is prevented successfully. For UET, there is an integer overflow in the transfer from function. There are also a few layers of checks. These checks are invalid, as the value transferred should not be greater than allowance, or what the sender has, and it is only overflowed when the sum of the balance of the sender and value transferred is lesser than its balance. This results in tokens transferred even when sender has insufficient tokens. The previous check we used for BEC token does not prevent the attack but provided useful information for developer to figure out the issue. The emitted events showed that the transaction went through and the assertion error showed it failed the test we written. In conclusion, due to badly written code, millions of dollars are stolen from Ethereum. By looking at how instrumentation can be combined with tests, we provide a proof of concept to developing a fully automated testing framework. Thank you.